all, have a good day. I am K. Surya, working as Assistant Professor in the Department of ECE at SNS College of Technology. So in this video lecture series, let us see some topics on transistors and their applications. So in this video, we will see about the basic principles of bipolar junction transistor. W. Shockley, J. Barden and W. Breton invented the transistors in 1947. The term transistor is derived from the words transfer and resistor. These words describe the operation of a BJT, which is the transfer of an input signal from a low resistance circuit to a high resistance circuit. So first we will see what is a transistor. So a bipolar junction transistor is a three-terminal semiconductor device that consists of two PN junction diodes which are able to amplify or magnify a signal. It is a current controlled device. The three terminals of the BJT are base, collector and the emitter. A signal of small amplitude applied to the base is available in the amplified form at the collector of the transistor. This is the amplification provided by the BJT. Note that it does not require an external source of DC power supply to carry out the amplification process. So transistors will act either as a switch or as an amplifier. It also regulates and controls the flow of current in the electronic circuit. So Bell Labs introduced this in 1947, and initially it was made up of germanium, and all the current transistors are made up of silicon under the process of doping impurities into the original pure silicon material. So doping is nothing but adding some small amounts of other impurities or elements to create an additional protons or electrons. So based on the type of doping, there are two types, p-type and n-type. In the p-type, the dopants lack a fourth valence electron, that is a boron or aluminum example. In the n-type, dopants have an additional fifth valence electron, example phosphorus and arsenic. So current only flows from p to N. So this is the symbol of bipolar junction transistor. So you will be having emitter, base and collector, and you will be having two junctions, emitter junction and the collector junction, which is represented here as JE and JC. Based on the doping, you have two types of transistors, NPN transistors and PNP transistors. So next we will see the construction of bipolar junction transistor. So here it is constructed using the basic PN junction diode. So this PN junction diode can operate in the forward bias or the reverse bias condition. So in the forward bias condition, it allows the current to flow between the P to N, and no current will be flowing between N to P in the reverse bias condition. Here one important thing, breakdown voltage is there. So sufficient N to P voltage of a Zener diode will allow for the current to flow between in this direction. So before going into the operation, we will see few more points on the construction of bipolar junction transistor. So it's a semiconductor device that is constructed with the three doped semiconductor regions, that is the base, collector and the emitter, separated by two PN junctions. Bipolar transistors are manufactured in two types, NPN and PNP transistors, and are available as separate components, usually in large quantities. The prime use or function of this type of transistor is to amplify the current. This makes them useful as switches or amplifiers. They have a wide application in electronic devices like mobile phones, televisions, radio transmitters and industrial control. So next we will see about the operation of a bipolar junction transistor. There are three operating regions in a bipolar junction transistor. First one is the active region, the region in which the transistors operate as an amplifier. Next region is the saturation region. Here the region in which the transistors is fully on and operates as a switch such that collector current is equal to the saturation current. Next one is the cutoff region, the region in which the transistor is fully off and the collector current is equal to 0. So there are two types of bipolar junction transistors, PNP transistors and NPN transistors. So first we'll see about PNP transistor. So in the PNP bipolar junction transistor, the N-type semiconductor is sandwiched between the two P-type semiconductors. The two P-type semiconductors acts as the emitter and the collector respectively, while the N-type semiconductor acts as the base. So this is shown in this figure. And on the right side, the symbol for PNP transistor is shown where the arrow mark is inwards. So current always flows from positive to negative. So arrow mark direction is inwards. Next one is the NPN transistor. So in the NPN transistor, the BJT P-type semiconductor is sandwiched in between the two N-type semiconductors. So here the two N-type semiconductors acts as the emitter and the collector, and the P-type semiconductor acts as the base as shown in the figure. So current entering the emitter, base and the collector has the sign convention of positive, while the current that leaves the transistor has the sign convention of negative. So functions of bipolar junction transistor are based on the two types, namely NP and PNP, and on the doping types of the three main terminals. An NPN transistor consists of two semiconductor junctions that have a thin p-doped anode region, and PNP transistor also consists of two semiconductor junctions that have a thin n-doped cathode region. The flow of charge in a bipolar transistor is due to the diffusion of charge carriers between the two regions belonging to different charge concentrations. Regions of BJT are known as base, collector and emitter. The emitter region is highly doped when compared to the other layers. Both collector and base layers have the same charge carrier concentrations. Among these junctions, the base emitter junction is always forward biased and the collector base junction is always reverse biased. Forward biased means p-doped region has more potential than the n-doped side. So we will see the operation of the transistor. So the basic operation is described here using a PNP transistor. The operation of the PNP transistor is exactly the same if the roles played by the electron and holes are interchanged. One PN junction of a transistor is reverse biased, whereas the other is forward biased as shown in the figure. So both biasing potentials have been applied to a PNP transistor and the resulting majority and minority carriers flows are indicated in the above diagram. Majority carriers will diffuse across the forward biased BN junction into the N-type material. A very small number of carriers will through N-type material to the base terminal, resulting in the current IB, and it's typically in the order of microamps. The larger number of majority carriers will diffuse across the reverse bias junction into the P-type material connected to the collector terminal. Few applications of BJT are it is used as a detector or also known as a demodulator. BJT finds applications in clipping circuits so that the waves can be shaped. Logic circuits and switching circuits use BJT. Let us take a few assessment questions. First one is, what are the operating regions of the BJT? Yes, we know that the operating regions are forward active or active region, then reverse active or inverted region, saturation region and cutoff region. Next one, what are the applications of BJT? So BJTs are used as amplifiers, are used as oscillators and used as demodulators. Thank you for watching this video.